So hi guys, so in today's video we would be looking at GANS. I know it has been a really long time since I uploaded a video. Actually I was on a leave. So from today I would be continuously again uploading videos on, as usual, a topic machine learning and deep learning. So GANS is one of the most important topic when it comes to deep learning, and for this particular video I haven't made my own material. I haven't combined any material at a specific location. I've used a lot of materials from specifically from Google and MIT. So I would be giving you the links to all of these materials in the description section, and I would recommend you all to go and learn from these materials, as believe me, these are one of the awesome materials that is available on online, that is related to deep learning and generative adversarial networks. So let's get started into the video. So GANs are one of the most interesting ideas in computer science. So if you would ask me what is basically GAN, I would tell you that two models are trained simultaneously by an adversarial process. What is adversarial process and all things, I would tell you in detail. So just imagine these are the two boxes drawing right now, and yeah, so a generator, the one thing is a generator, I would mark it as G, and then another thing is discriminator, that is D. So a generator learns to create images that look real. So what did this particular function do is, from the name itself, generative adversarial network, you must be getting to know that this is not something where you tell the prediction, you don't tell the accuracy, but instead you generate something. This is the part where machine learning model gives you something from what it has learned. So while a discriminator, generator generates something that learns to create images. From generator name itself you are getting to know that the generator must be doing something that is giving output to us. And from discriminator you must be getting that it learns how to tell images that they are fake, either they are I would just mark it as fake, that is false, or real, that is true. So these are the two things that must be happening. So let me tell you the function. So you can call generator as the artist, and the discriminator as a critic. You can just imagine this as a movie, or a painting, that the artist who paints the painting is the generator, and all the crowd, all the people who come there to see the painting and give their reviews about it are the critics. So a neural network try to create the pictures of a particular object. For now, let's take images of cat. Let me name this CAT, that is cats. We are taking images of cats. So this is a neural network which is trying to create pictures of cats that look real. Means it's trying, it's not 100% sure that it, at the very first attempt, it would give you a picture that looks very real. But the discriminator is a neural network that examines cat pictures and determine that are those cat pictures real or those cat pictures are fake. It tells us that. So from here itself, thousands of real world images labeled cat are given to it. So you must be thinking, how does discriminator tells that is this cat picture real or fake? So for that we give around thousands and lakhs of pictures to this particular discriminator model to learn that okay, these pictures are fake, these pictures are real. And after that, all the images that are generated by this generator are given to discriminator, that okay, discriminator, we have already taught you in thousands of images that these particular pictures of cats are real and these are not. So now tell us that all the pictures generated by this generator are real or not. And once discriminator gives some output, suppose I have given it one picture generated by generator, and I gave it discriminator labeled it false, that okay, this picture is not real, it is fake. This output will be given to generator, that generator, your picture has failed, you need to improve yourself. And this is how slowly the accuracy graph of generator increases. It increases something like that. And once the discriminator starts giving all the pictures of generator as true, that these are real pictures, you can just accept the fact that yes, generator has been trained successfully and it is giving us really accurate pictures. So let me show you that why generator nowadays are abused. I would just this is the PPT which was used by MIT in one of their course materials. I am taking reference from this because these are the best examples. So why generative models? So the outlier detection. Suppose there is a problem that how can we detect when we encounter something new or rare. The strategy here is leverage generative models, detect outliers in the distribution, use outliers during training to improve even more. From here, what it is giving, that you generated something but still it is not perfect. Maybe it is 90% perfect. Maybe the image that is generated by the generator is 90% perfect, that is looking real. But what about that 10%? That 10% is detected by this discriminator. And from after that, the generator improves itself and tries to give more accuracy around 95%, 97%, and at 90, suppose at 98% the discriminator is saying that it is real. Hence 98% is the point of 90 to 98%, that 8% is the point where the model has improved itself. So yeah, suppose you can see the edge cases, detect outliers to avoid unpredictable behavior when training, the harsh weather, edge cases, the pedestrians, and some real life examples if you want to see, those are here present in the N2. You can see the GANS for image synthesis, the latest results. These images are not generated by, are not real. These are generated by the generator. You can look at these three images. Believe me, at the first sight when I saw it, even I was surprised to listen that these three images are totally fake. They are generated by a computer, by a GAN, by a machine learning model. These are not real images. Hence, this is how accurate a GAN can be. So I think we have talked a lot about it. I took the same example. So let's talk about the training. So coming to the training part, uh, during training the generator progressively becomes better at creating images that look real, while the discriminator becomes better at telling them apart. The process reaches equilibrium when the discriminator can no longer distinguish between real images from fake. So this is the part where I told you this or this that 8%, that is 90 to 98%, that is the part where training takes place. So yeah, this is how you can look at this example. The first attempt by generator was this. This is of that cat only, and the generator started making images, and this was the first attempt, and discriminator said no, this is fake image. After that, generator made another image after many attempts later, and discriminator again said okay, 50% of it looks real but still 50% is fake, so I would consider that as fake. But after a lot of attempts, generator finally made a really awesome image, and after that discriminator looked at that image and discriminator passed that image as real image. Hence this is how things work in GANs. So this particular notebook demonstrates the process of the minis dataset. The following animation shows a series of images produced by the generator as it was trained for 50 epochs. So I would recommend you to go over. I would give you a brief intro. So even Google would recommend you to learn more about GANs. Go to this Intro to Deep Learning course that is available on YouTube, and these are the PPTs to it. You just need to go to Intro to Deep Learning and just enter it, and you would be good to go. This is the website where you can learn it. This is the particular video deep generative modeling. For now I would just be back at the place where I was. So yeah, coming to the part, simply we would import TensorFlow, we would install the GIFs that we need to, and these are all the modules we would be needing. We are preparing the minis dataset. This is the means the generator will generate handwritten images resembling the minis dataset. These are the part where we train images, the dataset splitting, the buffer size, batch size, and the training dataset is equals to from tensor slices. So yeah, the generator uses tf.keras.layers.cont 2D transpose layers to produce an image from a seed, hence starting with a dense layer. So this is the generator model code. I won't explain everything in detail because it would make the video really long, and I want you to go and study that in detail. So this is the generative model, make generative model, and this is where we as use as it at the untrained generator to create an image. And you can see this is just not even an image, it is just the pixels pixels randomly allocated at an image. And now we make the discriminator. So this is a CNN based image classifier. You must be familiar with it. We have done a lot of models, layers.com, everything is same. And you know, the best part is we are using leaky relu. If you have seen my activation functions video, you must be knowing that how much I love leaky relu. Now coming to the part discriminator, we are printing the decision, and this is the how the discriminator looks like, the shape and everything. This is the loss and optimizers, and then we have discriminator loss, we are defining generator loss, we are defining, and the discriminator and generator optimizers have been defined. We are using Adam because Adam is the bestest optimizer that is present currently right now, as I have already told you. Sorry for that. Now we will save the checkpoints. We will define the training loops, number of examples to generate, and the training loop begins with the generative uh, receiving a random seed as input, and this is the TF function, train step, and after that the training, and the generate and save images. Define generate and save images, model, epoch, and test input. The predictions, figure, everything has been defined, and the training would take a bit long, believe me. It took a half an hour for me, and this is what I got the result. We saved the checkpoint, and after that we display a single image using the epoch number. I would just display it once again, and this is how the GIF has been defined. If I try to open it in a new tab, I guess. So this is what the model has generated, and you can see the generated GIF right now. I would just open it here. I guess it's, yeah. So this is the generative GIF by the model. You have seen a lot of, gave it a lot of GIFs like this, and this is how what we got in result. So I think that's not a bad result. So for this is it for the video. I would give you the link to all the material that I have used in this video in the description section. I would recommend you to please go to this PDF and read about GANS, and I will make sure that I will cover this particular PDF and research paper in detail in my upcoming videos, in which we would talk about GANs in detail, in depth. And this is the MIT intro code to deep learning course, and this is it for the video. I hope you have got an idea what particularly GANs are and where they are used. This was just a brief video, don't worry, we would cover it in detail when we talk about it in this research paper. So thank you for watching this video, thank you and have a nice day.